Hello, all of you. Welcome to my channel Chemistry by ANR. This session is for discussing about how many stereoisomers a particular compound can produce. First, we are discussing about 2-chlorobutane. The simple example, 4 carbon atom, 1, 2, 3 and 4. Here we can see there is one chiral center and the carbon number 2, which is the chiral center, has Cl. So in the first structure, I am drawing Cl as a wedge bond. So now, since there is only one chiral center, as per the formula 2 to the power of n, the number of stereoisomers will be 2. So in this case, we can see the wedge CCl bond and the dash 1 CCl bond. These two are the difference in the two structures, and structure 1, this is structure 1 and this is structure 2, and these are the two stereoisomers because there is only one chiral center present in the compound. So what is the relation between these two compounds, these two stereoisomers? Please notice that there is no internal plane of symmetry. There is no internal plane of symmetry over here, and so this is not meso, this is enantiomer. That is the relation. So the next example, 2-bromo-3-chloropentane. 1, 2, 3, 4, 5 carbon atoms. 2 position there is bromo, 3 position there is chloro. So carbon number 2 and carbon number 3, they are the two chiral centers. So for them, we can say for this compound n is equal to 2. What is n? Number of chiral carbon or chiral center is n. So for two chiral centers, number of stereoisomers is 2 to the power of 2. So there are possibility of forming 4 stereoisomers. So let us try to draw. This is number 1. Number 2, I can change 1. So I have changed the CCl bond. I made a dash bond here in the second structure. Since there is a change in one chiral center, it's a diastereomer. And understand what is a diastereomer. It's a stereoisomer that is not a mirror image of each other, and it occurs with difference in spatial arrangement at one or more stereo centers. When you are drawing the structure, keep in mind that if there is only change in one chiral center, it gives rise to a diastereomer. If there is a change in both the chiral centers, then it forms enantiomers. That is the non-superimposable mirror images. So carbon number 3, when I draw, compound number 3, when I draw, I try to change, just to alter the structure that has taken place in carbon number 2. So what is happening if I compare the structure 1 and 3? There is only one change. So it's a diastereomer. The compound 2 and 3, see the structure. So 2 and 3, there are two changes in carbon number 2 and carbon number 3, both the carbon. So they are enantiomers, non-superimposable mirror image. Draw the fourth one where I can draw both as a dash bond. So here compound 1 and compound 2, there are changes in center 2 and 3, and so 1 and compound 4. Compound 1 and compound 4 are enantiomers. They are not having any plane of symmetry. What is the relation between the structure or compound 2 and 4? They differ at only one carbon. See 2 and 4. Let us see structure 2. Here we can see CBr. Okay, this is CBr and this one is CCl. CCl is a dash and CBr is a wedge. But in structure 4, the CCl remains dash and the wedge bond also becomes dash. So there is one change. For that reason, 2 and 4 is diastereomer. 3 and 4. What is happening in 3 and 4? Let us see. In 4, there are two dash. In 3, this bond is a dash and this bond is a wedge. So, again, 3 and 4. What is the relation? 1 change. So it's a diastereomer. So keep in mind this as a trick. When the structures have change in one center, that is a diastereomer. If both the chiral centers change in configuration, that will give rise to enantiomer. Let us try to apply this, and if there is any internal plane of symmetry, it will form a meso compound, optically inactive. So let us try to draw the structures of 1,2-dibromocyclohexane. These are the structures, and here again we can see there are two chiral centers, carbon number 1 and carbon number 2. They are the chiral centers. It should have 4 stereoisomers as per the formula 2 to the power of 2. So now how many we can form? This compound 1. This is one form where we can draw one wedge, the other also wedge. Now compound 2, I am keeping the wedge and I am changing 1 to dash. So this is compound 1. What is the relation between 1 and 2? There is one change, so it is a diastereomer. Now try to draw the third compound where I am changing both. I have made it dash in both the cases. So 2 change. So what is the relation between 1 and 3? And what is the relation between 2 and 3? Let's first see 2 and 3. In 2 and 3, there is one change. And this is the change. There is one change. This is the change. So 2 and 3 are diastereomers. What is happening in 1 and 3? In 1, we have an internal plane of symmetry. There is an internal plane of symmetry. And in 3 also, there is an internal plane of symmetry. So for this reason, these are meso compounds. 1 and 3 are meso compounds. It has internal plane of symmetry. So we can consider them to be one structure. They are identical and they are considered to be one compound or one structure. What about the fourth one? Fourth one, you can keep carbon number 1 as dash, carbon number 2 as wedge. See, we don't have such. So just altering this structure. Altering this structure, we get here dash and here wedge. So what is the relation between 2 and 4? In 2, what has happened? In 2, this carbon number 1 was wedge, carbon number 2 with Br was dash. So here in 4, we are seeing dash and wedge. Both are changing. So it is enantiomer. There is no internal plane of symmetry. Now if we calculate how many stereoisomers are there, see over here that 2 is one structure, 4 is one structure, and 1 and 3 is identical because it forms meso compound. So in total, there are 3 stereoisomers and not 4. So when you are trying to write this, be careful to see whether there is any internal plane of symmetry or not. In that case, the structures will be meso structures. They will be mesoforms. And so the number of stereoisomers should decrease. So I hope this section was easy to understand. If so, I will be waiting for your comments in the comment section. So, bye all of you.